Hi, everyone. People are joining in, so I'm unable to respond to every single person who's joining in, but welcome. This is TAOCP number 1, our inaugural meeting. So please feel free to chat amongst each others. I'm just setting up a few things with the slides and the recording, and we'll get going around 10 past 2. Okay, I think I've got the slides going. Hopefully everybody can see the slides. The slides are just there to let us know where we are. I'll be just sort of changing the slide to indicate what we're doing, but there's not a lot of presentation. We're focused on reading and discussing. And I've got the chat on the side. I've also got the shared document that I did uh, send the link for to everyone yesterday. If you RSVP'd after yesterday, I don't think you would have gotten that link. So I'll try to paste that in the chat. But the idea behind the document is that, if you have some longer notes that you want to enter into a document and um, not into the chat window, then you can do that in the document. But otherwise, you can just use the chat or just speak. Hi, welcome. This is TAOCP number 1, the inaugural meeting. We'll get going in just a few minutes, but feel free to chat amongst yourselves. Okay. By the way, I'm Zartaj, for those of you who joined after I introduced myself earlier. I'm in New York, and I think most of our attendees are from the New York area. But it would be great to know if you're from outside New York, even if you're from New Jersey or, somewhere close by, but not strictly New York. If you could just either speak up or let us know in the chat, it would be really cool. And so I am recording this, and I did put up the link for a YouTube channel that I've created. It's empty right now, no content. So this will be the first video. Hopefully, everything will go well. We'll have sound and video and everything, and we can post that. And then along with the notes, and there's a repo for exercise solutions. So hopefully we can build up something that people who are either not able to attend a particular meeting or just are interested in studying or following the text on their own, they have some resources that they can use for sort of this discussion group to help them out. So we'll get going in about 5 minutes. Just give everybody a chance to join in. Okay, cool. So Hoboken, that's over there across the way. Watchung, New Jersey. I'm not sure where that is. Where is Watchung? Is that northern New Jersey or central?
No, it's more central.
More central.
I'm about an hour away from the city proper.
Okay, cool.
Yeah, it's good stuff. There's a lot of mountains here. You guys should come hike.
Hello.
I've actually hiked in northern New Jersey, a couple of reservoirs there. So yeah, it's really beautiful. Uh, and Lake Hiawatha, where's that in New Jersey?
It's where 80 and 280 meet, so it's north central New Jersey.
Okay, very nice. Bergen County, yeah, I know where that is. Bloomfield, New
Morris,
Jersey, between
Morris,
Newark and
Morris.
Montclair, know where that is.
Yeah, Montclair is east of here. No, it's Morris County.
Okay, Parsippany, wow, that's a good representation for the area, definitely.
Alan is answering where Lake Hiawatha is because everybody knows Parsippany.
Yeah, definitely. Yeah, I did try to pick, a time slot where, I mean, obviously I'm in New York and I would expect most people from the New York area, or at least, in the same time zone to be more interested and active. But I didn't want to exclude, I want the possibility of people like in other parts of the US and maybe other parts of the world. So I, sort of came up with this time slot that I think could work for a lot of time zones in a day. So hopefully, we can keep this going and build up a community. Hi, Yuri. I'm Zartaj. Welcome to the TAOCP first meetup. We are going to get started in just a couple of minutes. So here's a little question. If you could just enter your responses in the chat, just to get a sense of, what everybody is interested in or looking forward to. If you know a particular section of the text, please enter the very specific section number or reference. If it's just some topic or, general feel that that the text covers or the volumes cover, then let us know of that. And then we'll just go over the responses in a few minutes. So Michael says, I'll be impressed if we cover any significant portion of it. And, it's taken Knuth, what now, almost 40, 45 years, 50 years, over 50 years to produce like 4 volumes. That's a lot of work. So I would imagine it would take us at least that amount of time to understand the whole thing that he's written up. So that is, yeah, I agree with you. I would also be very impressed if we cover any significant portion of it. And I'll explain like in more in the second half, like the structure and sort of the plan that I feel like would be very effective in terms of this huge amount of material. We'll go over that in a bit more detail. So James Curran says, since the parsing compile sections haven't been written yet, I'm looking forward to the searching. Yeah, well, searching is pretty early on, so we should be able to get to that, at least, the introductory material relatively soon. Graph theory, combinatorics, algorithms, yeah, I mean, there's a lot of stuff in there. So that is definitely a go-to reference for a lot of the stuff. And again, I think some of the concepts we may be able to cover early on, but like really heavy-duty graph theory, algorithms, it may take a while, but we'll get there, hopefully. David says, I'm looking forward to the exercises. Yeah, I mean, the exercises are so cool. In fact, one of my first things that really impressed me about the text. I mean, obviously, I'd known it for a very, very long time, but it was a particular exercise, and I may mention that in the second half. And my response was that one of the main motivations for starting the meetup and sort of getting around to this concerted and structured effort this time around was really SAT solvers. And that's the satisfiability problem. It's covered in volume 4B. That as a whole has yet to be published, but there's a fascicle out on that. My entire life, he started just before I was born. I see a note in my copy in the section of directed acyclic graphs, which I ended up using in several projects. And wow, that would be really cool. I don't know if you are able to talk about those, but at some point that would be really nice to learn about that. The second half generally will be reserved for more, free form topics of discussion, exercise, working on them, and like any problems that we have worked on before. So yeah, that would be a good time to talk about things like that. Okay, so I think that we are past the 10-minute mark. Here's the agenda. So for the next 45 to 50 minutes, we'll be reading and discussing. And, for those of you who have read through the text, in whatever manner, you probably know that it is pretty dense. There's a lot of stuff in there. There's a lot of stuff that is not even that technical, but it's very interesting and very sort of thought-provoking. A lot of stuff that I learned, just like ordinary general things about history and about people. So there's a lot to discuss as well. So what I plan to do is to just have us read a couple of pages at a time. So my idea is that we would read for about 5 to 10 minutes. So whatever that material seems reasonable to cover in 5 to 10 minutes, we'll do that. And then we'll discuss. And while we're discussing, we'll go over the chat and anything that's entered in the shared document link. And, please just feel free to enter stuff as you're reading into the chat. If you've kept notes before, just copy them in there. And yeah, just anything, like any ideas, any questions, comments, thoughts, whatever it is, doesn't matter. And then, so on average, let's say we spend about 15 minutes for 2 to 3 pages. We may end up with like 10 pages, 15 pages at a time. That's the idea. Now, obviously, if we follow that routine in a very strict linear order, we'll never get past even sort of the first chapter, I think. So again, in the second half, I'll go over the structure and the schedule that I've come up with initially. This is tentative, so it could change, but for the most part, I think I have a pretty good course charted out for us that'll get us through some preliminary material pretty quickly. But at the same time, we won't lack sort of the foundation for more advanced topics. Hopefully, after we're done with the reading, in about 50 minutes, we'll take a break, a 10-minute break, and then we'll reconvene for the second half. The meetup will stay up. The video will keep recording. And today, we'll go over the meetup structure and schedule and just talk over things. But usually, we will do exercises. Yeah, so this basically just covers what I explained about how we're going to proceed with our discussion and reading. There's a little note about if you want to use the shared document, the shared Google Doc, then just to keep everybody's notes easy to find and separate, I'm just asking for people to create a new page level section, and I've explained how to do that. The instructions are also in the document itself. So it should make it easy for everybody to find their own notes. And I leave the shared option on for like a day after the meetup as well. So, you can enter things later, but maybe a day or two afterwards, I'll post it to the GitHub repo, and then, you can just do a pull request if you want to add something to it. So, as you know, or those of you who have read the text to some extent know that Knuth has a lot of quotes throughout the volumes. He generally introduces each section with a couple of quotes. They're often, pretty interesting, often very funny. And so I have one from Knuth. So I know that my books still aren't terribly easy to fathom, even for geeks, but I could have made them much, much harder. So with that sort of note of gratitude, I guess, we can start. So we are now going to be reading pages from Volume 1, Fundamental Algorithms, and it's going to be a couple of pages from the preface, pages 5 and 6. This is pretty like general stuff, so I think 5 minutes is enough. But I'll give everybody 5 minutes. Right now it is 2:17, so maybe around 2:22. We'll just ask people if they've read through it. And again, just enter your thoughts, comments in the chat or in the shared document. We'll go over that in 5 minutes. Welcome, Anthony. We are right now reading these pages, 2 pages from Volume 1, Fundamental Algorithms, and we will be discussing those 2 pages in a couple of minutes. Okay, anyone need more time? Are we good to go over the first 2 pages? So Arthur is asking, the preface in his third edition goes all the way to page 11. That's mine as well. We stop around the outline of what. Yeah, so right, we will cover those entire pages of the preface plus a couple of later sections as well. But we'll do them like 2 pages at a time. And yeah, I mean, you will be able to see like where is a natural, beginning of some other major topic within that section. So yeah, you're absolutely right. So it looks like we have a definitive answer on how his name is pronounced, which is great. Yeah, I myself had always heard Knuth, so that's the way I pronounced it. And second edition preface goes to 13. Yeah, so I have the third edition. So yeah, if you have some earlier edition, you may need to reconcile the differences. So any comments, any questions, thoughts on those couple of things, couple of pages? So one of the things that I, was thinking about when I read it, like these 4 prerequisites that he mentions, and he summarizes them by saying that anyone who's written 4 programs is good to go. Like, that should have given you enough experience to tackle this text. And any thoughts on that? Agree, disagree?
Well, I assume that meant 4 programs in 1962, which would be quite different than writing a program these days.
That's very true, although this is the third edition, so if he's left that in there, then you would assume that he's still sort of sticking by that benchmark or rule of thumb.
Right, but now you can write a program that's like dragging and dropping things. So
yeah, I do agree. I do agree 100% that times have changed so much. Like in 1962, people who had written 4 actual programs would be a very select group of people, but now it could be like 8-year-olds. So, but the other thing that I feel like is that he is addressing, in my opinion, this text to an individual reader, maybe a person who is studying it in some academic environment, right? And so there's a lot of assumptions that go with that. Whereas I feel like in a sort of discussion group, reading group, there's a lot of help and thing and sort of resources you can count on, and you're not as sort of pressed for time. It's not as formal. So by the time we're done with the introduction to the computer, which he calls MMix now, which is a successor to the original Mix, we will have written or at least understood 4 programs. So I feel like we will have the prerequisites before we actually start to look at algorithms and other programs. Okay, so anything else?
I think it's also interesting that he assumes that if you've written 4 programs, that means you at least have some inkling about registers and indexed variables, probably some, paper tape or something. You've encountered these ideas, whereas I think these days, if you've only written 4 programs, you probably don't even know what a variable is, maybe? I mean, it really depends, right?
Can you write a program without a variable?
That doesn't mean you know what it is, though.
You don't know what
He's
it
coming
is.
from the assumption, I think, that people are sort of banging low level on the machine, and until the machine does what they want, and have no analysis. And this book is going to teach you the analysis of algorithms, or that algorithms exist. These days, it feels to me like people may come from the opposite direction of, okay, I know, I heard President Obama talking about bubble sort the other day, but but I have no idea what a register is.
Yeah. The hour of code. Yep. Anyone else?
Something that this is me again, but something I was a little puzzled by personally was the non-numerical analysis bit, where he seems to have a very definite idea of what numerical analysis is, and I guess I don't. So he's like, well, this is everything that's not numerical analysis, specifically analysis of algorithms. And I thought, well, then what is numerical analysis? Why would you write a book about that?
Any ideas? Anything to help out Arthur's dilemma? Well, I personally felt, to me, and that's just me, numerical analysis was very, very specific and clear, because there are college level courses titled numerical analysis. So it's sort of like, and there are books. There's a very famous book. It's by CRC Press. It has, I think it's called Numerical Algorithms. And so this is stuff like finding the roots of equations, extrapolating, interpolating, just dealing with numbers and equations and functions and mappings and a lot of approximation, floating point computation. So in my mind, I think he makes a point of this because in the early days of computers, that's the majority of the applications. So, I think he's sort of addressing this wider audience and saying, you guys are familiar with numerical stuff, but what I'm doing is not that. Like my focus is the non-numerical analysis. And it's interesting that he has the second volume is actually called semi-numerical algorithms, which is sort of like he has some number stuff in there, but he's applying them to not the numerical analysis applications. He's saying that this stuff is useful even for what is not strictly numerical computation. But yeah, I mean, these words are very general, so they can have a lot of meaning. I hope that helps.
By numerical analysis, he would mean the same sort of book of analyzing algorithms, but they'd be algorithms for root finding or matrix multiplication or integration or things like that.
Yeah, something like that. I do think, I don't know if he says this in the book, but I just have this impression that somewhere or the other he does say that analyzing those kinds of algorithms is often like very hard and tricky. But yeah, you're absolutely right. Okay, so Peter has some example. 1968-73, when the first edition was written, writing a program was an afternoon at the IBM punch card machine. Yep, absolutely. All right, so that actually I wanted to forward my slides. So we were discussing. I think we're done with that, and so now we'll go on to the next couple of pages, which is pages 3 pages, I guess, 6 through 8, like the end of 6, where he starts to outline the books through page 8 in Roman. We'll give about 5 minutes again. Okay, are we good? Good to go on some thoughts and comments?
Nothing particularly from me this time.
Okay. Anyone else? What did you think of his definition of analysis of algorithms? I guess we covered a little bit of it in that previous discussion. So he defines it as the theory of the properties of particular computer algorithms. What is your sense of analysis of algorithms? Like, what did you used to understand it as, and is this any different from what you used to think it was? Like,
Well, I would certainly think of analysis as being like big O notation, you know, linear time, constant space, whatever, that kind of thing.
yeah, and that's exactly what it is. But it is something that he introduced, and he sort of popularized that use in the world. So it's interesting to see like what he was thinking when he came up with that usage of big O, and what he was sort of saying should be the analysis of algorithms, because up to that point nobody really had uh, a clear idea of nobody talked about the analysis of algorithms as such. I think that's what he's saying. And it was interesting to me that the properties that he says is sort of the theory of the properties of particular computer algorithms. Like, he used that word particularly. Um, so he's sort of like saying, you have this algorithm A, you have this algorithm B, and he actually does use letters in the text, as you'll see. Um, so which is better? And how is it better? Like Arthur said, is it better in terms of using space? Is it better in terms of efficiency in time? Um, is it better in the worst case? Is it better in the average case? What do we mean by the average case? Like, all of these things that we've sort of taken for granted. If you've been working in the field, you've been a programmer, it's sort of interesting to see this sort of going through his head at that time. And if you know the story, um, do you know the story of how he came up with the name of this field? Okay, so I think I saw this in some video or some podcast or something, and he said that uh, he had just joined Stanford and he was at some faculty party, and there were, people from other departments, and somebody asked him, "What do you do?" And he realized that he didn't have a good answer for them. Like, there was stuff that he liked doing and he did, but he wasn't able to come up with the name of the field. And so he came up with this name, analysis of algorithm. He said, "Yeah, this sounds good. That's what I do." And then he proceeded to sort of define it. Um, so that's pretty cool. What do you think about his outline, the plan for his life's work? Um,
It reminded me of a lot of software projects I've worked on. You always think big up front, and then when you get into it,
yeah,
it's a lot bigger job than what you thought.
yeah. Yeah, I think that's very true. But one of the things that he sort of gives as an explanation is also the way the field exploded, right? So when he started out and he was thinking like, okay, I'm going to write these books and I'm going to just cover everything, like the state of the art in the field, like all the fields, but he just couldn't keep up. Sort of like, not only was his original sort of plan exploding, but then other areas are coming into the picture. And yeah. What about the classic techniques? People who are familiar with portions of the book, do you feel like he has really delivered on that? Like, he says that he wanted to then focus on classic techniques. Do you think he's missed out on some classic techniques? So Peter says one of his contributions that first struck me was defining whether a solution of a problem was NP complete, i.e. could it be solved in finite time. Yeah. Amal says, glad he didn't go with dynamic program. Why is that, Amal? I hope I'm pronouncing your name properly.
Yes, you are. I just meant it tongue-in-cheek.
Okay.
But the story of how dynamic programming came about, which is a nerd smack. But I do, one of the things that struck me about his work is that his premise was to teach, not a technical manual. And this idea of giving the readers or the students the ability to ask why and discover, or the framework to get to an answer themselves, was the first textbook that I encountered that had that point of view. It's kind of very Feynman-ish as well, like, you know, very reminded me in that these two people did the same work for teaching and elevating an entire generations into these very technical fields.
Absolutely, absolutely. That's something that's very easy to take for granted now and just assume that, you know, all these textbooks that are out there, you know, just have always been there. Yeah, absolutely. Okay, so let's move on to the next few pages, which will be pages 8 through 9 of the preface. I'm sorry, it's 8 through 11, actually. My Roman is like basically the end of till the end of the preface. Yeah, the O'Reilly, I noticed that about the Safari editions. It's annoying. Um, so I could add like a text snippet. Yeah, I'll do that in the future. Thanks. Okay, anyone need an extra minute or a little more time?
Yes, please, just a
Okay.
few more minutes. The edition I had did not have that quote by Bill Gates.
Okay, so what are your thoughts on the hardest decision he had to make?
I'll jump in.
Yeah.
The idea of the premise of if he wants to analyze something, to stick to the core, to where the machine, the machine code, I think is a great choice. Or like, well, it's interesting because he put thought into it. And the languages, removing the abstractions of what a compiler can do, and all the other complexities that can go in before you actually study the output, and you can be consistent in what you're generating from source code. I think that was genius, because now we're faced with so many choices. We put something in, but we don't know. Was it optimized? Was it not optimized? What's happening? And to just focus from your idea to the implementation, just to measure that, is important, right? Eliminate all the other cruft. I think that's really beautiful.
That's great. He's given 6 reasons, A through F. Any one of these that you don't like 100% agree with or think it's not relevant anymore?
Well, I think reason E is interesting. The machine language would be necessary anyway because we're going to write programs that output machine language, which ties into how he wanted to do, volume 5 on lexing and parsing, and then compilers really going into the language, like programming languages and compilers area, which I'm also like super into, but I did feel in the last section, like, is this really all there is to CS? Is it just building up to make it your own compiler, or is there more to it? So I think he's doubling down here on this idea that, yeah, we're going to build up to, like, finally we can make our own programming language. Like, a programming language is just a tool for making other programming languages. And I'm not real comfortable with that, but I'm not really sure what the alternative is either.
Those things that Larry Osterman, who is a longtime programmer at Microsoft, he's been there like 30 years or so, and he wrote an essay where he said, for my entire career, I've been telling people, you gotta learn machine language. You gotta really understand deep down into the computer. And recently he decided, like, no, you really don't need to know machine language anymore.
Any other opinions? Like when you read these things, these reasons and sort of his explanation, how did you feel, like viscerally? I mean, if you've been programming, like, did you have some kind of immediate reaction, like, oh, I mean, come on, is he, like, does this even really mean anything today?
My reaction was he was almost, and maybe this is kind of off base, but it's like he was almost proposing, I'm just going to kind of pseudocode this. I'm not going to, this doesn't have to actually really work. And yeah, I deal with this a lot in our, sort of application development process. We have people that throw things into, documents and hand it over to programmers like it should just work. So, I mean, I feel like it's a practical measure, because when you do have to worry about things working, it gets very complicated quickly. But maybe as the other gentleman was saying, he's if he's dealing with things at a lower level than what's typically done at pseudocode is kind of capturing business sort of interaction or requirements at that higher level. I don't know. Yeah, I'm kind of interested to see how this works out with what he means by this sort of mythical machine and language.
I was into computers and programming for the early 80s, and the reading it from that perspective, I was excited, because we didn't have these options you have now, where you could get an entire stack in the cloud to do something. It took a lot of effort to get there. We're standing on shoulders of giants, kind of thing. But from the perspective, I think that makes me think that when he was writing this, that was the horizon he was able to see. And that's what was, I think, he identified as the most important things to be efficient in across the tool sets that were available then. I do wonder what he would say now. He would probably revisit it. He might even, I don't know. I'd love to know what he thinks about JavaScript. But I think, for me, like reading it now, like 50 years after he wrote it, this book, it's like the context of the world has changed, but some of the ideas still translate. Big O is important. The ability to analyze and ask why, it's important. The platform he may have chosen was better for his time, but it aged, and it may not be the best platform for modern or current developers.
Yeah, if I may add something, when you wrote in the 70s that he was doubting between Fortran and Algol, both are very imperfect languages for expressing those things. I'm a statistician by background, so Fortran was back then the only thing we had for numerical work, and Algol was used in computer science curriculums more in Europe than over here, and it was a very awkward language for a lot of practical work. So I can see at that point, Mix was a good choice. Whether it's now whether C is, which came from the Unix system developers, it's much more of an expressive language without all the trouble that Mix has in its expression. There's actually on his homepage some question that they ask, what is your favorite language? So I guess you can read that for yourself. But I think back then the lack of a good programming language, I know that how people were excited about Pascal as a language when that came out, because they didn't have the problems of algo, Fortran, and so forth. But Pascal remained for mostly a, academic language, as opposed to, even though it had for a while, it had a Turbo Pascal was pretty big, but it was more of an academic language than anything else. So yeah, the question now is, what would he have seen? But I don't think having the knowledge of assembly language is necessarily a drawback. If you're this level of study, it kind of comes natural. There are more difficult things than expression, than the syntax you have to learn.
James asks, is it worth learning assembly language today? So he's pasted a link, some YouTube video. By the way, please feel free to paste any links, any references you find interesting, relevant to either the chat, which I'm going to copy into the shared doc, or the shared doc directly. And again, we want to, obviously we want to have a discussion and interaction during the meetup, but since the video is going to be posted, the document will be available publicly to anyone who's interested. These will be really useful, pieces of information that people would be able to find. So somebody was going to say something.
That's the video I mentioned before by Larry Osterman, saying why he stopped saying you need to learn assembly language.
Cool.
On the subject of language choice, one of my favorite books, actually, that I've been reading since like middle school, probably, because it was on my parents' bookshelf, was The Elements of Programming Style by Kernighan and Plogger, right? TJ Plogger. And it was all PL1, but which I didn't really, know at all. But you sort of get it by osmosis, and that worked really well for them because they were talking about style, and they could just look at the code and say, well, look, if we do it this way, it's not as good as if we do it this way. This way is shorter, it's cleaner, it has fewer jumps around, and you could see that even in PL1. Whereas what Knuth is going to be doing here is analyzing specifically the performance. And that is a case where it really needs to work. It's really critical that the code be correct. And I mean, not that it wasn't in the other case, that was kind of the point. But that the code's meaning needs to be unambiguous, right? If it's ambiguous, it can't be correct. And something that we certainly see these days with C and C++, and also, I guess, Python has had one major jump and many little jumps. If you write a book in Python today, 5 years later, people are going to be saying, well, why did you use that syntax and not this one? Well, that didn't exist back then. Or, your program doesn't compile anymore. Well, yeah, because they changed it so that we reuse the same name for different languages. And by controlling that dependency, right? Take no external dependencies, vendor everything into your book, even if it means vendoring in the language that you're going to write in, and having to describe that in your book. That solves the ambiguity problem.
There's a couple of great links in the chat. So one, obviously, the assembly language worth learning today. And then Thompson says there's a great 2-hour interview with Knuth done by Lex Friedman recently. And I have actually watched, I couldn't watch the whole thing. It's pretty long. But the pieces that I watched were really great. It's amazing, actually, how active Knuth is at his age and his project. He's talking all over the country. He's being interviewed. So there's a lot of material for you to find, to understand his point of view and clarification. So yeah, anything that you can post in terms of links, references, that's really cool. Thank you. Yeah, James says he's 82. Any other thoughts, comments? So I gave him a B+ for his decision. And the B+ is sort of like a regex. So it's 2 Bs. So it's, in my opinion, bold and brilliant. And I think for his purpose, like he really doesn't want to do any kind of hand waving. He doesn't want to say, this is just take it for granted. Trust me. This is what it means. This is why it's correct. And I feel like he just wanted to remove all of that cruft and all of that layers of stuff that happens when you are dealing with a higher level language. And the syntax he mentions, obviously, but things change, like Arthur said, and you don't know what the compiler is doing. And you don't know, like, you would have to really, if you wanted to do that level of analysis, I mean, he would just get um, like lost in the code that's being generated. And so this way he has control. He can say, okay, here's this instruction. This is exactly what it means, and there's nothing else. And I only need this, right? For this algorithm, I only need these instructions and combining them in a certain way, and I know exactly what it means. And we'll see when we start discussing mmix. And it's actually, for a long time, I didn't even used to look at that piece. Like I would go to the books, and if I had something I wanted to understand, like a new field or new algorithm, and I would just read the pseudocode and I would kind of just ignore the assembly. But now when I start to actually read the assembly, especially mmix, which is the modern version, it's very straightforward. Like, not, I shouldn't say very, but it's a relative term, but compared to say picking up C++ or picking up Python, you can actually do this, and I hope that we will prove this. We can actually do this in a few sessions, and you will know everything about mmix, and you have the complete power of a Turing machine, and you can write any program in it. A little more verbose, sure, but very, very clear syntax and very, very easy to understand. And the mmix version is much nicer than the original one. So, you'll see if you haven't seen already. So I would say this is just great. I agree with everything that he says. But again, I didn't really pay much attention to this. Like, it's only when I started to read this now that I kind of, said, "Oh wow, he's absolutely right. He's absolutely right." Even if you were writing this book today, like starting out today, I think he would need to do this. There's a need for those other books as well, but there's a need for this book as well, for this level of treatment. And I think there's really no way around it. You have to go to each individual instruction, and you'll see the way he analyzes algorithms. He needs those individual instructions. He has to count, code paths, and so it becomes very tricky when you're dealing with something that's being generated by a compiler.
It's also important to see that when he talks about a language, it's about algorithms. It's not about, do I write an operating system in Mix? Do I write a relational database system in Mix? It's really just the algorithm. So it can be fairly compact and something that the brain can capture. It's not like 10,000 pages.
Exactly. The subject matter and his focus is on these algorithms that are classic, that are sort of the kernels of all these applications that we are developing and people are developing all over the world. And generally these are, smaller, very self-contained and very well-defined solutions to problems. So that's to his advantage as well. Yeah, absolutely. Okay, so we have gone over 3 p.m., but I think we will take a break. We're done with the preface. The next couple of sections were there's this very interesting flowchart that he's given as a procedure for reading this set of books. And then there's some notes on exercises. I think we'll come back to the notes on exercises after the break because I don't want to go on for too long continuously. So we'll take about a 10-minute break right now. It's 3:04, so maybe around 3:14, 3:15, we'll reconvene. And again, we'll go over the notes on the exercises, which is, just very general sort of reading. And then I'll go over the structure and sort of the plan going forward and the schedule and we can just discuss anything else that anyone's interested in. So feel free to turn off your cameras, refill your coffee, and whatever that you would like to do or need to do. All right. Okay, so we are back. We'll just give a minute or two for people to return. And when you return, if you could just spend a couple of minutes reading the notes on the exercises section.
Hi, Zartaj. What did you mean about the notes on the exercise section?
So that is after the preface. So right after the preface, there is a section titled something like a procedure for reading this set of books. There's a flow chart that goes along with that. So we're going to skip that. And then that's followed by a section that's called Notes on the Exercises. And this is it starts at page 15 in Roman. It just explains how his exercises are structured, and he has a rating system um, just so people can get a handle before they attempt an exercise, like how difficult and what um, sort of background you would need to attempt the exercise. It's very straightforward stuff. So yeah, I think people will probably have either read it or gone through most of this section. Um,
Yeah, I'm
any,
following along. I'm
yeah,
following along on the listed PDF, and I don't have that page. It
you
goes
don't have that
from
page. Yeah, so yeah, maybe it's missing from your PDF. It may be an older edition or a different edition. I'm not sure. But again, um, it just has, so you can pull up the end of any section in the book, the later sections, and there's exercises there. And if you look at the exercises section, you'll see that in brackets, he has a number, and sometimes he has a letter or two with the numbers. And so all he's saying is, and by the way, this notes on the exercise section is repeated in multiple volumes, I've noticed. So you can go to any volume. If it's missing from this particular PDF, you may find it in other ones. Anyone care to explain like his rating system?
It goes up to the contents. Like if you get to the table of contents, you've already gone as far as we're going. And then after the table of contents, it goes to chapter 1. So if you hit chapter 1, you've gone far enough.
Yeah, it's not in the PDF that was posted.
Yeah,
I see it
I can
in the
read that.
O'Reilly copy.
I don't want to screen share any actual content, because of copyright violations and things like that. So unfortunately, I can't show you the page. But he has this rating system, which is very unique. But he has six general categories for the numerical rating. So 0, 0 is immediate, meaning the answer should be obvious to you. It should just come out right away. 1, 0, or 10 is simple, and he expects you to take about 1 minute for a problem that's rated 10. For a problem that's rated 20, he says this is a medium level problem. He expects 15 minutes to be spent on that. And then 30 is moderately hard. 40 is a term project, like a semester. 50 is a research problem, meaning, yeah, as far as he knows, there's no solution to this. It's an open area. And then in between, it's sort of a logarithmic scale. So 10, 11, 12, it's not a linear increase, it's a log. It's sort of like the Richter scale, right? So going from 7 to 8 is not just one level. So 7.1, 7.2. So he's basically given you that sense of how long and how hard a problem is. And then the other symbol that he has an M. If the problem requires some mathematics at the level of, I guess, high school mathematics generally, but some mathematics. And it's not just pure code or algorithmic sort of solutions. And then HM is higher math, by which he means college level math or calculus. Could be analysis stuff where you need some integration or derivatives or things like that. Limits, most likely. So then he has some exercises. The first exercise, it has a rating of 0, 0. And the exercise is, what does the rating M20 mean? So what's the answer to that?
Mathematically oriented.
Right.
And
it's an obvious mathematically oriented question.
20 would be not obvious according to him. So it would require a little bit of time.
I thought it was M0.
quarter hour.
Quarter hour, right. Yeah, and again, this is Knuth speaking, so I'm not sure if we can take him at his word for this. But yeah, I've noticed that he's not off by a lot, but sometimes it takes me a little bit longer than what he's saying. Question number 2 is, it's rated 10, so you shouldn't need more than 1 minute to come up with an answer. And the question is, of what value can the exercises in a textbook be to the reader? So I'll give a minute, and anyone who wants to volunteer.
So he says something about that somewhere in here. I wonder if I can find his words fast enough. But when you work on exercises and you discover the answer for yourself, that it helps it stick in your mind more than if you just read it.
Yeah. And I don't think there's a single answer to this. So if anyone else has other answers, I think the idea is that you can come up with an answer within 1 minute. So whatever it is, should be fine. Any other answers?
What he said was, we all learn best the things we have discovered for ourselves.
Yep. Okay, if no more answers, then question number 3, which is rated 14. So this would be somewhere between simple and medium, between 1 minute and a quarter hour on a logarithmic scale, probably, 8 minutes? Something like that? 7 minutes, 5 minutes, not sure. Prove that 13 cube is 2197. So he's saying 13
Also,
to the power 3.
Shouldn't that be M14?
No, because I don't think it requires any unusual mathematics.
Yeah, that's a good point, though. It is math, but it's not the kind of math that he says you need, like this extra level of math. There's some math, like counting and some other basic sort of maybe middle school, up to middle school stuff that he's saying, okay, I'm just not going to say that that's sort of a requirement. That's just assume you have that much knowledge. But if it's, something beyond that, where you need to do manipulate some formulas, maybe, I'm not sure, but that's my understanding. High school math is M, HM is college math. That to me is my understanding. Prove that 13 cube is 2197. Generalize your answer. And in brackets, he says, this is an example of a horrible kind of problem that the author has tried to avoid. So,
and I looked up the sample solution, and there is no solution. But it makes me wonder what he meant by generalize your answer, or if that's part of the horribleness.
Yeah, I think that's part of the horribleness. That is exactly the horribleness. The things that are, deliberately kind of vague and sort of unclear what he would mean, like what the questioner actually means that you should be doing, and maybe there is no answer. Exercise 4 is labeled HM45, so higher math, at least college level math, and 45 being somewhere between a term project and a research problem. Prove that when n is an integer, n greater than 2, the equation x to the n plus y to the n equals z to the n has no solution in positive integers x, y, and z. Yeah, so James has an answer. He's saying for all values of 13 cube is 2197. So is all like in all possible universes? Yeah, that's very true. So question number 4, anyone know what this problem is? Anyone seen this problem before?
I know like Fermat's theorem is if it's 2. And I thought they said someone had like discovered the proof that it's not true for anything else.
Isn't that Fermat's theorem? It's Fermat. Yeah. If it's squared, then if it's 2, then it's just
quadratic. Okay.
They're called Pythagorean numbers if it's 2, and there's lots of solutions like 3 squared plus 4 squared equals 5 squared, but there's no solutions in positive numbers for I don't think it's I don't know whether it's even been proven. When I was in college, which was a long time ago, it was not proven.
Yeah, so you guys are absolutely right. This is Fermat's last theorem, and you can look it up. One of the most famous unsolved mathematical problems still about the early 2000s when this mathematician, not far from most of you guys, actually, most of you folks in New Jersey, he proved it. And I think it's been accepted. Like, yeah, this is a solid proof. So, but at the time, I think the 3rd edition came out. It probably had not been proven. So it's kind of funny. But yeah, so that's sort of the idea. Yeah, go ahead.
You can tell that it's been proven in the 3rd edition because it's marked HM45. Right? If it were an unsolved research problem, it would be 50.
You may be right. It would be interesting to know what the earlier editions had it as. Somebody had a 2nd edition. What does it say in the 2nd edition?
It is 45. It is 50 in the.
It's 50 in the. Okay, cool. There you go. So he's consistent. Yeah. So that's very nice. And yeah, so that's the idea. We don't have a lot of time during the meetup. So we definitely want to do some exercises. And so that's what the second half is going to be. And but we won't really attempt anything beyond a medium, right? So even within the medium category, there could be a lot of really challenging problems that could take a bit of time. So we'll we just want to have like some exercises so that we kind of understand like what we are supposed to do with this stuff. But really, it's up to you folks to, depending on your level of interest and the time that you have, how much time you want to spend. I do want to provide an opportunity for us to become familiar with his terminology, his structure, his layout. So, you can use this as a reference effectively, right, on your own. So that's sort of like the idea. Not only do we progress through the book, but you'll have a sense of like, oh, where would I find this in Knuth? Like, does Knuth talk about this, and what are the exercises that could be interesting for me to understand? So that's sort of the general idea. And yeah, so now going on to our meetup. Yeah, so let's discuss the schedule and the structure. And so first of all, here are all the books in case somebody is not aware of what we're taking on. But yeah, so there's a lot of books. These are sort of the core of all of his entire project, and these came out like relatively early and regularly in his career. Um, this is the order in which we are going to see these books or need these books. So volume 1, obviously, that's where we've started. Third edition is out for a while. Then we are soon going to get into, I think the third meetup is going to be the computer that Knuth is targeting and using for his solutions for his program. And it's called the MMix. And it's you can interpret it many different ways, but one way that he suggests is that it's Roman numerals, so it's 2009, because that's when it came out, or when he announced it. And what he's been doing since volume 3 is that because each volume became such a huge undertaking, he began to release material in smaller booklets that he calls fascicles or prefascicles, and he made them available for free on the internet as PostScript files that you can convert to PDF. So he started to do that with a lot of material that became volume 4A. And so fascicle 1 MMix is another one, and this is available for free if you look it up. You can download it, and so we'll be going and studying that very soon. So that has the computer, this ideal hypothetical computer, which essentially is sort of the instruction set architecture. So what are the instructions for the computer, the machine language level? And there's assembly language that allows you to combine and to write programs using those instructions. So that's like another step above the instructions, and it's very straightforward. It's like really you will be surprised just how not difficult it is. Then accompanying that, the fascicle 1, which is just purely the MMix computer and the assembly language, there is another book or booklet called the MMix Supplement. And this is not by Knuth, but by another person named Martin Ruckert. And this book is very useful for us because what it has is equivalence of the references to the older computer that Knuth used in his original first 3 volumes that are still in print today. So the first 3 volumes have not come out with updated editions that are using MMix. So a lot of people got together and they started to write programs and the text that would allow you to use MMix in the place of the original mix computer. And so that's what we'll be doing. We'll be using the mmix supplement. It gets a little tricky and confusing. I'm hoping that after a while we'll just kind of get used to it. But yeah, there's no getting around it. It is problematic. We'll have to switch between the mmix supplement. It'll have some snippet of text or code that you're supposed to read instead of what's actually in the volume. But I feel like mmix is really worth understanding. It's much nicer and much easier than mix, especially if you're familiar with computers these days. So mix is, yeah, it was hard for me to kind of get my head around like the mix instruction set, but mmix felt much easier to me at least. Then once we've gone through, once we become familiar with the mmix, the computer, the assembly language, which will take us about like 6, I think, sessions, the way I've planned it out, 6 or 7 sessions, we can then go back to volume 1, fundamental algorithms, and there's some initial preliminary stuff that we will do, maybe half a dozen, maybe even less than that, like 3 or 4 meetups. But I want to then get into sorting and searching. So I think that by like the 10th meetup or something like that, maybe even a little earlier, 10th or 11th, we should be able to read portions of volume 3. And that's where sort of the real algorithms begin. And then we'll be sort of just going back and forth. We'll pick certain key algorithms or sections, data structures from volume 3, and we'll go back to volume 1 using the mmix supplements wherever needed to fill in sort of the prerequisites for that. So it will be very nonlinear, but I'm hoping that we will be able to sort of get to the meaty stuff soon, and then we'll sort of build on that. Volume 2 does have some very interesting and useful material, but I don't think we'll need it right away. At some point, we will need it. It has some stuff about numbers and discrete math that's a little more advanced. And there's some interesting random number stuff in there, some statistical stuff that's really good for analysis of algorithms. But again, it will be a while before we really need volume 2. So like the first couple of months at least, it'll be volume 1, the mmix booklets, and volume 3. Volume 3 is sort of our goal, our goal right now. Then there are the newer books, so volume 4A has a lot of relatively modern combinatorial graph theoretic algorithms, very, very interesting stuff. But again, we have to get through sort of the foundations before we get there. And I will try my best to get us there as fast and as sort of reasonably quickly as possible. Volume 4B, which has not yet come out, it's comprised of these fascicles that are again available for free. If you just search for them, or I think from Knuth's homepage, you may be able to find references or links. But it has these very specialized topics, and this is like really new stuff. This is like 2000s. A lot of new papers, a lot of new fields. And the one that I was interested in is satisfiability, which is fascicle 6A, mainly because I had to deal with a problem that led me to satisfiability, and I felt like, yeah, I could have used this material to solve my problem in the first place. But according to Knuth, this is like a very successful area, like a set of problem-solving approaches that has proven really successful for solving difficult problems. And then there's, Hamiltonian paths and cycles, a lot of graph theory stuff. Fascicle 9b, which I haven't had a chance to look at, has some puzzle related stuff. But yeah, so there's a lot of standalone, really interesting topics in there. And if you, at some point when we are looking at going beyond the first 3 volumes, please indicate your interest. And you have, to some extent, initially. I did ask that question at the start of the meetup, like what section or topic are you looking forward to? So, but yeah, feel free to add your input to that. And what is the schedule going to be? So the idea is that, this is going to be a weekly meetup, Saturdays. I'm committed to it, and I hope anyone who has time can join us. But I will be doing this same time, 2 to 4 p.m. As I said, I wanted to. I am in New York. A lot of people are in New York. I hope this time works for them. But I also wanted to pick a time that would allow people, say, on the West Coast, if they're interested, to join in. It wouldn't be an ungodly hour for them, and possibly people in Europe or anywhere else in the world. So this is kind of like my compromise time, but it has to mainly work for New York and the East Coast in general. So I hope that is okay. And at some point, depending on how much interest there is and what the level of participation is, we could have one-off meetings. These could be things devoted to or covering some more advanced mathematics, like some deeper analysis that Knuth is talking about. He has these starred sections that are kind of optional. And depending on the level of interest, we could have a meetup that goes over some of these sections that would be considered not necessary for sort of the main path that we're following. And it could be just any other thing as well. It could be just some other algorithm or field that I don't know. I mean, it just remains to be seen. But yeah, there could be some one-off things, but there would be some other day or some other time. It could be after hours on a weekday. It could be during lunch on a weekday. I'm not sure how that'll work out. So it'll be up to you folks to decide what we want to do in that regard. So the structure, I wanted to give you a flavor right away, like what the structure is going to be, and hopefully we can stick to this. I may be a little optimistic into as far as how much stuff we can actually read and discuss in the first hour. I think I'm definitely a little optimistic. So we may need to skip something sometimes and maybe then save it for the next meetup. That's always a possibility. But I have put up a tentative schedule that I'm revising almost constantly. And but the next few meetups, the general trend, I think, is pretty. You should be able to get a pretty fair idea if you just go to the GitHub repo and look at the tentative schedule. So yeah, I mean, we're going to focus on algorithms and programs. Knuth clearly identifies those. He has names for algorithms, like lettered names. He has names for programs. For the algorithms, he uses a kind of pseudocode. For programs, of course, he'll use the mmix assembly language. And we want to build a foundation to follow and perform analysis, but we don't want to do the analysis too much, right? We just don't have the time for that. That's like, it just requires concentration and stuff that you have to kind of work out on your own. But I'm hoping that focusing on algorithms and programs will make you appreciate and kind of motivate the need for the analysis. If you don't already have it, I'm sure a lot of you already have that motivation. And then in the second half, again, we'll work on exercises, simple and medium, maybe a couple, maybe 3. We may discuss past or future topics, exercises that people have worked on, got stuck on, or want to show their solutions, talk about it, anything else of interest. But, like medium term, maybe not medium term, but longer term, maybe like a year out or so. I want to get to 4A and the stuff from 4B. I mean, that is the goal. I mean, Like, I want to get to those topics and find what is needed from the first 3 volumes that will enable us to talk about relatively current stuff. And again, we'll pick what that is supposed to be. I have some ideas, but if you have other ideas, if you would, if there's like a strong interest in some graph theory field, some particular section that you want to target, then we can figure out like how do we get there? Like what is the minimum that we need from each chapter? And so, that we'll be hopscotching through these earlier volumes, figure it out. Next meeting is next Saturday. And again, I will try to post, not try, I mean, I'll definitely have the agenda laid out, and I already have for a bunch of future meetups. But we will start with this algorithms section. It's relatively short. It's sort of a general introduction to the idea of an algorithm, its history, very interesting. There's some appendixes that will prove useful when you're reading through the book, and we'll just sort of look at that and see what's there. But that's pretty much it. So it's relatively light material, again, for the next meetup, just to give you a sense, and for people who may be not programmers yet, just to give you an idea of that. But then in the third meetup is essentially where we will start the computer, the NMIX instruction set and the assembly language, and that'll go on for like about half a dozen meetups. And again, you'll be surprised, I'm sure, happily, like, compared to many other programming languages, how straightforward it is. So, yeah, any thoughts, comments, feedback?
I was wondering, do you think it would be do you think it's important for us to do the reading together? Or would it be a good idea to do some of the reading beforehand so that we can just discuss during the sessions?
That's a great question. And so realistically, I think that to sort of get the most out of the meetup, you should, or if you have read it in advance, and if you have sort of spent some time thinking about what's in the text, you would get the most out of the meetup. And that's what I've been doing. I'm not reading it right here. I've already read it. I've added my notes. That's what the shared document is for. But to ask people to do that, I'm not sure how realistic that is either. Like, there are people who are busy and who may be familiar enough with the material that they don't actually need to read it in advance. And if you just give them 5 minutes, that's good enough for them. Like, yeah, but they do need a little bit of time to read. So that's all I'm doing. I'm just saying, we'll give you a little bit of time, like enough for just in terms of reading the text, not thoroughly understanding it. And the hope there is that some people who want to get the most out of it, or who are willing to spend enough time ahead of time, they will have done the reading, they will have thought about it, they will have thought-provoking comments, questions, ideas that they will have either added to the document or they'll post it in the chat. And then people who are just coming in, they just read it, they'll still get something out of it, right? Like, even if you don't have that background and strong foundation, you just spend 5 minutes reading it, you understand like the English part of it, right? I read something, I understood it. And then there are people, I will have read it, I will, start some discussion if nobody wants to, or whatever it is. Like, I'm hoping that at each level you can get something out of it. That this is just an opportunity for us to meet and to have this community, to have sort of a group thing. I don't want to use this analogy, but like a group therapy session for any kind of problems that you're having. Like people have had their problems for years and years, right? But they still go to the group therapy session because they want to talk about it, right? They want, like, somebody may not be aware of the problems, and other people may have analyzed the problems for a long, long time. It's an opportunity for us to come together and just say, here's what I think. Um, and as long as there's some value that you can provide at whatever level, I think that's great. I just don't want to make it a requirement. I don't want to give homework. I don't want to say that this is like, please read this, and if you come in and you haven't read it, like, wow, what are you doing? No, I don't want to do that. I mean, we're all busy people, and as I said, a lot of people who may be interested in the stuff have probably read this and really understood it, but still want to participate and sort of share in that experience. So that's what I'm hoping for. Does that answer your question?
Yes, it does.
Okay.
Thank you.
Cool.
I was thinking, like, instead of like having this little pause where we all read it individually, could we have someone like read it out loud? You probably have to pause the video to avoid copyright issues, but people watching the video are going to fast forward the pause anyway. So
yeah, that's actually a great idea, and that was my first idea, that we would actually read it aloud. But then I was looking up sort of the copyright, the rules, and yeah, so we can't even read it aloud. So I would have to really just sort of fiddle with the video, and and if I make a mistake, then YouTube will take me down, and it's like we just cannot have any actual copyright content in any form reproduced without permission. So yeah, that would be really nice. If we were meeting in person, we could do that. And that would be very, very nice to get everybody synced up. But I'm hoping with the slides, and I'll be sure to add some text snippets as well. So even without the page numbers, we know where we are. That we're kind of synced up while we're in the meetup. But yeah, other than that, how much preparation you want to do, how much time later you want to spend, that's entirely up to you. So some resources that I have alluded to and also mentioned, and also I think sent out in the email. But this video, when I'm done with it, it will be posted to the YouTube channel. Then we do have the GitHub repos. So there's 2 repos there under the Art of Computer Programming organization. One repo is called Meetup, which has everything to do with sort of the Meetup notes and the agenda and stuff like that. And then there's an exercises repo that, of course, is related to our Meetup, but it's really meant to be standalone. Like anyone could contribute solutions to the exercises. I've tried to keep the format for each one of these repos and the content, the text, like as simple as possible. So it's just markdown syntax. You just write it in text, and hopefully, again, it'll be of use to us individually, and also to any other people who are looking for resources and references to help them understand with the text. There's a Facebook group that's just for anything people want to post. So if you want to join that, please do. And yeah, I think that's it. So I really am so happy, so thankful to all of you. I was prepared to do this alone. Like I was thinking, as I said, I had this motivation for this topic, and I thought, okay, so maybe I can just start from the very beginning, and I'll just live stream like what I'm reading, what I'm understanding, and I'll do that and then post it on YouTube. But then I thought, okay, maybe there's other people who may be interested in the stuff too, and so let me try that. So it's like even if one of you showed up, I would have been very, very happy. But 16 showed up, so that's really great. So I am very thankful. Yeah, so if you can find the time and attend, that'll be great. If you can catch up, attend whenever you can, that'll be great too. Yeah, so anything else? Anything you want to comment on, discuss, talk about?
Well, Zartaj, I'm really, really happy you did this because I was thinking of doing something very similar.
Okay.
And it's been many, many years removed since I had to look at this, but I feel it's in my best interest to revisit it again.
Thank you.
So thank you.
Okay, then if that's it, then thanks for coming. See you next week.
Thank you.
Yeah.